All right. Hello, everybody. It's my pleasure to start the next REBASE session. Right now, we will have 3 talks. We start with Eddie. So without any further ado, the floor is yours.
Thank you. Again, my name is Eddie Aftandilian. I'm a principal researcher in GitHub Next. I was a member of the original GitHub Copilot team, and I led some of our more recent projects, specifically Copilot for Docs and Copilot Workspace. And today I'll be sharing some lessons that we've learned from building these GitHub Copilots. Can people hear me? Can you hear me in the back of the room? No. Okay. Hello, can you hear me now? No? Hello? Hello, hello? Do I have to get this close? Still can't hear? Hello, can you hear me? Okay, that's better. How about from here? Or do I need to stand like right at the mic? Maybe I'll just hold it. Okay, is this good? All right. Okay, so I'll be sharing some lessons that we've learned for building GitHub Copilots. So in case you haven't heard, AI developer tools are changing the way that we write software. And GitHub Copilot was one of the first such tools. It launched as a technical preview, essentially a closed beta, in June 2021. Today it has 1.8 million paying users, and 50% of those users' code is written by Copilot. For context, estimates are that there are maybe 20 to 30 million software developers total in the world. This is a pretty good chunk of like all software developers in the world. And other companies such as Google report similar proportions of AI-generated code for their comparable AI code completion tools. And this is only going to increase as the next generation of tools comes online. These are tools that approach the problem at a higher level. For example, completing an entire development task as opposed to completing a line of code or a function. These are tools like Copilot Workspace, Devin, Cursor, and so on. In GitHub Next, we build AI developer tools. We're a research or advanced R&D team within GitHub. We created the original GitHub Copilot in collaboration with OpenAI. We also created something that was branded as Copilot X, which included Copilot for Docs and a few other projects. And most recently, Copilot Workspace. And along the way, we've also tried a bunch of stuff that didn't succeed. And so we've learned a lot from working on AI developer tools for the last 4 years. And today I want to share some of those lessons with you so that everyone can build great AI developer tools. I'm here representing the work of an amazing team. Currently we have 19 people. We have a couple of new people who are not represented on the slide. We have a mix of backgrounds and skill sets. We have some front-end developers. We have back-end developers, we have ML researchers, we have programming languages researchers, we have user researchers. And it takes this diverse mix of skill sets to build successful AI developer tools. And so I'm going to share these lessons that we've learned over the last 4 years, and I have divided them into 2 broad groups. The first are organizational lessons, and this next are technical lessons. And I'll conclude with the 3 most important lessons that I want you to take away from this talk. So the first category are organizational lessons. Setting up a team to do this kind of innovation work is actually very difficult, but having the right organizational setup is critical to making it work. The first organizational lesson I want to share is to think big. Being a research team within a big company is a precarious job. You're different from all the other teams. You're not delivering immediate value to an existing product, like a product or engineering team. And what you work on is risky, and much of what you try is going to fail. And so for this kind of team to succeed, you need to bet on things that have the potential to deliver asymmetric value far beyond the effort required. Now, you might ask, is it realistic for a small team to think big? It's more realistic than you might think. And here I wanted to share the example of Original Copilot. When Original Copilot was introduced in June 2021, there were fewer than 10 people on the team. One of the great things about software is that a small team of great people can build something with huge impact. And this is what I meant by asymmetric value on the previous slide. In addition, building an ambitious new thing can actually be easier to do organizationally than shipping an incremental improvement to an existing product. If you're trying to get a new feature into an existing product, there's a product team you have to interface with. You have to convince them that they want the thing that you're building. And if you build it and try to hand it over to them, they might balk because you're treading on their turf. You'll run into all the standard problems of tech transfer that industry research teams struggle with. But if you're building something totally new, then there's no team whose turf you're treading on, and you don't have to get their buy-in. We call this non-adjacency, and it's a core principle in Next. Does our idea represent an incremental enhancement that GitHub engineering would naturally do at some point? Or is it a fundamental rethinking of a problem that we're uniquely positioned to solve? We want our projects to fall into the second category. Back when we created Copilot, GitHub wasn't building IDE extensions and wasn't working on code completion. And this made it easier to make the case to launch this project. The next lesson is to deliver tangible results frequently. If you're thinking big, it can be tempting to talk about multi-year time horizons. It's okay to have a long-term vision and an overarching plan, but you need to drop off useful things regularly, or it's going to look like you're doing nothing. And the example I wanted to share here was some of the work we did on neural retrieval. In late 2022, we built a homegrown vector database to experiment with. Retrieval was a hot topic in the ML literature, and we wanted to see what it might be good for. We first used it to explore natural language code search with a deliverable of a live demo at the GitHub Universe conference in October 2022. While it demoed well, the quality of the search results wasn't good enough for a real product, so we moved on to another application. Next, we used it to experiment with customizing Copilot for private codebases. Because Copilot uses standard models that were trained on public code, they're not aware of a company's private code, internal APIs, custom programming languages, and so on. And so we were looking for a solution to improve quality on these private codebases. One way to do this is to index the private codebase and store snippets in a vector database, and then as the user is typing, you query the database for similar code and inject it into the prompt. So we implemented this, and we ran an offline evaluation and got a very positive result. But when we ran an online A/B test in Copilot, we didn't see any improvement in our key metrics. And we had another application for retrieval, so we handed this result in our code to the Copilot team, and we moved on. By this time, ChatGPT had been released, and everyone was excited for chat. We realized that you could use retrieved snippets to ground an LLM chatbot in high-quality official documentation. We also realized that you could retrieve from private documentation as well as code to customize the chatbot for a specific company. So we refocused on retrieval-augmented chat, which turned into Copilot for Docs, which launched as a technical preview in March 2023. With the retrieval work, we were able to deliver 3 useful things, each taking a few months, along the theme of investigating neural retrieval. Next lesson is to create urgency via deadlines. Setting deadlines focuses the team, it forces you to make hard decisions, and great teams will rise to the challenge. These have to be real deadlines with an external commitment. People are smart and will see through fake deadlines. The academic equivalent here is committing to a paper deadline, and I'm sure you've all seen how much progress you can make in the week before a paper deadline. You do have to be protective of team health. You can't always be crunching. You need to balance these with less intense times when the team has room to explore new ideas. And the example here I wanted to share is Copilot for Docs again. So we had this vector database lying around, and we were able to build a demo very quickly once we got this idea. So we built that demo. This demo got sort of shown around to executives, and we were immediately asked, why haven't you shipped this yet? Could you have it ready in 8 weeks? So I went back to the team, we discussed it, and we decided to go for it. And once we made that decision, it became a sprint. we couldn't argue about stuff for even a couple days. We had to make quick decisions and push forward. It was fun to rally towards something big. And even though it was intense, the people who worked on Copilot for Docs will tell you that it's the most fun they've had in Next. Next lesson is to be disciplined in project selection and continuation. Next aims for an 80% failure rate, because if we're succeeding too frequently, we're not being ambitious enough. This means that most projects are going to have to end before they reach their goals. It's tempting to let stagnating projects continue in the hope that they're going to unstick themselves or to avoid conflict. And in fact, many of these projects are not stagnating. They're progressing, but not fast enough or easily enough. Maybe they've hit a roadblock that is solvable with enough effort, but there's an opportunity cost to that. What are you not working on because you're working on this? And this opportunity cost is especially high in the LLM era, when models are improving exponentially. Also, the longer a project goes on, the more painful it is to stop it. If you've been working on something for a year, it's going to hurt much more if you have to stop that project than if you've only worked on it for a few months. Here's an example of a project that didn't continue, SpecLang. SpecLang was very ambitious. It explored whether you could write a natural language specification of a whole application and have an LLM compile it to code. And the core idea was that the natural language should be the source of truth, not the code. As we worked on this, we ran into some hard problems. First, it's very difficult to iterate when natural language is the source of truth. One of the principles of SpecLang was that you shouldn't need anything beyond the natural language spec to compile the same code every time. But in practice, it's really hard to specify an entire application in that level of detail, not to mention dealing with LLM non-determinism. You might get something close to what you want on the first try, but then you can't adjust just one part of the application via this interaction. And the second hard problem was that it's just hard to generate a full, real application from scratch. It's hard to specify how you want it to work, it's hard to break it down into components, and so on. As this project grappled with these hard problems, other projects sprung up that needed help. So reluctantly, we paused SpecLang. And SpecLang didn't fail. Its core ideas influenced the rest of Next and led to the creation of Copilot Workspace, which I'll discuss in just a minute. Next lesson is to beware of long-term project ownership. As a research team, your job is to invent new things. Time that you spend maintaining things that you've already built is time that you're not spending building new things. My teammate Idan Gazit has a saying, "You can't go exploring if you're carrying baggage." If you've ever been in the situation of trying to maintain an existing project while building a new thing, you know how hard this is. It's very difficult to justify spending time on something new and speculative when you have real users who are running into bugs in your existing thing, or who have feature requests that you know will improve their experience. But as a research team, you have to spend time on the new stuff because that's your job. And so it's very important that you not hang on to projects for too long. You need to get these projects to a point where they can stand on their own and then hand them off to a product team to own long term. With original Copilot, this was a long process. Those of us who had created Copilot in Next went on loan into GitHub Engineering to seed and grow the new Copilot team. We helped to get Copilot to general availability, we hired people who could take over our work, and we worked on knowledge transfer for almost a year to help build a healthy team that could own Copilot long term. Then we came back to Next and started working on new projects like Copilot Workspace. Next, I want to share some of the technical lessons that we've learned. And the first lesson is that UX is critical, not just in AI developer tools, but in any developer tool. In the programming languages and software engineering communities, we have a long history of building really cool, innovative, useful tools that no one uses. Some examples, refactoring tools, right? So people do use refactoring tools, but they underuse them. There are a lot of like really useful refactoring features that people never use. And there's been a line of research in the software engineering community investigating, why this is. Why don't people use refactoring tools? Static analysis tools are another one, right? So we talk a lot about static analysis tools here, but in practice, most engineers are really only interacting with, maybe a linter on a day-to-day basis, but not real heavyweight static analysis. Program verification or formal verification tools. I don't think I have to explain to this crowd how hard it is to get uptake of these tools. Even debugging tools are not actually very widely used. Even basic debugging tools like your debugger. I don't have hard data on this, but I would estimate that the majority of developers are just doing printf debugging. They're not using a debugger. And this list goes on and on. And I think this is because we haven't found the right UX to make these usable by real developers. And usually, the people building the tools don't have UI expertise to find this right UX. But getting the UX right can be the difference between success and failure. And here I wanted to show the evolution of the Copilot Workspace UI as it evolved from a prototype to a product. So Copilot Workspace aims to help a developer solve an entire development task, such as a feature request or a bug report. It takes in this development task as input, it finds the right places in a repo to address it, and then it modifies the code to satisfy the requirement. This is what the first prototype of Copilot Workspace looked like. It was an experiment by one of our team members, Don Syme. He had been inspired by SpecLang, but where SpecLang wanted the natural language to be the source of truth, Don wanted to explore keeping code as the source of truth, but enabling the user to modify it by editing a generated natural language specification. So he called it extract, edit, apply. The user would first extract a specification of the code in the repo with respect to some topic. Here it's called the pivot. Then edit that specification, and then apply that edit to the code to update it in the way desired by the user. Now, Don is brilliant, but he's not a front-end developer. And so you can see that this is rough, but it gets the idea across. And we've kept the core flow of extracting a specification and now a plan, and letting the user edit those and then apply or implement the changes in the code. This is the first publicly shown version of Copilot Workspace. It was demoed at GitHub Universe in October 2023, about a year ago. At this point, we had brought on our first front-end developer, Cole Bemis, and he totally revamped Copilot Workspace, and it looked amazing. Cole had previously worked on GitHub's design system, Primer, and you can see his fingerprints on this. It's now consistent with GitHub's design language, and it looks like a real product. After Universe, we brought on a second front-end developer, Turkel Gervig, and he revised the left-hand side with a timeline view. This makes it clear how you are supposed to progress through the flow. You start with the issue, you proceed to the specification, you generate a plan, and then you implement the code changes. This version lasted the longest, from around March 2024 until very recently. This is the latest UI revamp, which just became the default about a week ago. We heard feedback from our users that they wanted help from Copilot Workspace before starting to implement. Often you might have an issue where you don't actually know how to solve it, and users want to brainstorm possible approaches with the AI in the context of that issue in that repo. And so this version focuses on the brainstorming side of Copilot Workspace. You'll note that it removes the spec and plan. This is a big change and one that we experimented with for quite some time. While we're continuing to refine it, early feedback from users is very positive. We spent a lot of time and effort on the UX of Copilot Workspace, and we believe that having a well-designed and polished UX is critical to making it something our users love to use. Next lesson is to build a prototype ASAP. As researchers, our instinct is to run benchmarks and quantify things, but feel is actually very important when building developer tools. And to get a feel for a tool, you have to build a prototype and use it. Also, a prototype is far more convincing to decision makers than benchmarks. And as an example, I wanted to share a project I worked on at a previous job called FixBot. I started FixBot with the aim of automatically repairing code that doesn't compile using a model trained on source code edits. Oops. This was before LLMs, and so we had to train a model from scratch to do this. We started by collecting a giant data set and then training that model, then computing the fraction of failed builds that we could fix. We could map that to developer time and show huge potential productivity improvements. But my management wasn't convinced, and it took us years to do all this work. If I could go back, I would do the least amount of work necessary to build a prototype that we could show to the decision makers, let them use, and so on. A usable prototype is much more convincing than charts and graphs, even at a data-driven company. In addition, having a usable prototype lets you test your assumptions. In Fixbot, we had some assumptions that made the project significantly more complex. For example, we believed that we couldn't show fixes that wouldn't compile to developers, and so we did a lot of work to implement what we called speculative builds. But if we had had a prototype, we could have just tried using it before we built that feature, and maybe it wouldn't have been necessary. Or maybe we could find a UI that lowers the cost of these incorrect suggestions. The next lesson is to do the simplest thing first. As researchers, one of the mistakes we make is valuing difficulty or novelty, when really we should celebrate simple solutions to hard problems. This is doubly true in the LLM era. If you can solve a problem purely through prompting an off-the-shelf model, you should do that. You should only move to more complex solutions if you absolutely have to. And it's surprising how many problems you can solve with simple approaches. And for example, I wanted to share a Copilot feature that we built called neighboring tabs. In the early Copilot days, we would send context from only the current file to the model. But it was clear that context from other files could be useful as well. So we implemented the simplest possible form of this, where we looked at other files that were open in the editor, did a very basic textual similarity match, and then inlined the relevant code into the prompt. What we did not do was spend months discussing this, over-designing it, training embedding models, setting up a client-side vector database, and so on. When we ran the A/B test, the result was striking. The improvement was comparable to the improvement we got from switching to a newer generation model. It was the single largest improvement we ever got through prompting. And while we had a bunch of work planned to make this feature better, we never did it because the basic implementation worked well enough, and there were other lower-hanging fruit to pick. Next lesson is to build an evaluation suite. So I mentioned earlier that feel is important, but quality is also important. In order to make decisions about things like choice of which model to use, your prompting strategies, and so on, you need some way to measure quality. This doesn't have to be perfect, but it does need to give you, enough signal for you to make decisions. The example here I wanted to share is the Copilot offline evaluation harness that we built. So this was for classic Copilot code completion scenarios. And the way it worked was that we took real open source repos. We would clone these repos. We would install the dependencies and get them set up to the point that we could run their tests. We would run those tests with coverage enabled, and then we would look at the functions under test. We would select functions under test that had high coverage, and then we would treat those as targets for synthesis. We would blank out the function bodies of those functions, and then we would query the model for a replacement function body, and then we would rerun the test. And if the tests passed, then that would be considered a success, and if they didn't pass, that was a fail. Now, this offline evaluation harness was limited. It only supported 2 programming languages because we did have to figure out how to set up the dependencies and run tests in the language. So there's per language work we had to do. It only supported Python and JavaScript. And it also only tested full function synthesis. So, actual Copilot has multiple modes. It can suggest sometimes only a single line. Sometimes it will suggest to the end of the current block that you're typing, and sometimes it'll suggest a full function. But our offline evaluation suite only tested full function synthesis. So it wasn't perfect, but it gave us enough signal to make decisions, and it was especially important before we had real users where we could do A/B tests, which are kind of the gold standard here. Next lesson is to don't over-index on cost. We're in an era of exponential improvements in LLMs. This means that costs have been quickly going down and will continue to do so. And so we shouldn't prematurely declare projects too expensive. Instead, we should focus on delivering the most value to the user and assuming that exponentially decreasing costs will make it financially viable. When we built Copilot, there were existing competitors, but they were all using small local models, presumably for cost reasons. With Copilot, we were aiming for much higher quality, which required a large cloud-hosted model. It would have been easy to just decide that this was financially infeasible and kill the project. But instead, we focused on building the best tool we could and getting users to love it. And it succeeded. And over time, the models we use to power Copilot have gotten smaller and faster while quality has improved. We saw a similar thing with Copilot Workspace. When we started the project, we were using the preview version of GPT-4, which was terribly slow and expensive. But then GPT-4 Turbo came along, which was much faster and cheaper. And now we have GPT-4o, which is quite fast and quite cheap by comparison. Okay, lesson number 6 is keep an eye on the literature. And here I kind of mean the ML literature. The ML literature moves super fast, and it can be really hard to keep up with it. The models are improving exponentially. But if you pay some attention to the literature and maybe social media to see what people are talking about, it can be useful to see what new technologies people are excited about. And sometimes you want to make a bet about how you think things are going to evolve and start moving in that direction before everyone else. And the example here, again, is neural retrieval. So back in 2022, we were reading papers about retrieval-enhanced models, and it seemed like this could be an interesting solution to the problem of adding additional information to an LLM. So we built a simple vector database to experiment with, and that turned out to be the foundation of Copilot for Docs, which we were able to build super quickly because we already had that core technology in place. And then the next lesson is to dog food intensively. Dog fooding refers to the practice of using the things you're building. It comes from the phrase, eat your own dog food. And surprisingly, a lot of people don't do this, or they disregard the feedback when it's inconvenient for them. In Next, we dog food intensively, and we take the feedback seriously. It often results in substantial changes to the things we're building. And here, I wanted to show some examples from something that we call Copilot NES, or Next Edit Suggestions. Copilot NES is a current project that aims to take AI code completion to the next level. Original Copilot suggests code where the user is typing and only takes into account the current state of the file. Copilot NES takes into account the sequence of edits the user has made and predicts the likely next one. This edit doesn't have to be at the cursor. It can be somewhere else in the current file. For example, suppose I add a new parameter to a function declaration. Most likely, my next edits are going to be editing the call sites to pass that new argument. NES will suggest those edits away from the cursor. At the beginning of the project, we had a strong belief about how we should present those diffs, with strike-through text and a replacement in this light-colored text, which we called ghost text, like original Copilot does. When we started dogfooding it, however, we found that when the ghost text appeared, it would cause text later in the file to shift around in a very distracting way. Our dog fooders reported that it was very irritating to have their screen constantly shifting around like that. So we reluctantly implemented this side-by-side diff view, and it was immediately obvious that this UI was better. The team member who had been most opposed to it quickly admitted he had been wrong. And now it's time to shift gears and wrap up. If you take away only 3 lessons from this talk, I want them to be the following. First, think big. Don't settle for incremental improvements. LLMs are able to solve problems that were previously impossible, and our job is to figure out how to make these capabilities really useful to developers. Second, UX is critical. Building a great developer tool is not just about the core technology, but also about how easy and fun it is to use. Don't overlook this critical aspect of building AI developer tools. And third, dog food intensively. You really need to use the things you're building, and you really need to listen to the feedback and address it. Thank you for coming to my talk, and I'm happy to take questions.
Thank you. Okay. Thank you a lot for the talk. It was very interesting. I wanted to ask you, how important do you think it is? It would be to keep as a business motivation in mind, like an application for business. Like, is it more important to be able to dogfood something and do something that the researcher is excited about, or do you think that it's not worth doing it if you don't see a business application?
Yeah, so this is a good question. I actually think that over-indexing on business, like a business application, is a mistake. I think one of the fun parts about working on developer tools is that, like, as developers ourselves, we're our own users, right? So in a lot of other software domains, you're building software for users who are not you. Like, they have different characteristics. What resonates with you may not resonate with them. But in this area of developer tools, like, we're all developers, we all use developer tools. And I think usually our intuitions about what a useful developer tool is are actually correct. And so sort of over-optimizing for a business case might prevent you from building a more generally useful developer tool that can be broadly used. And I think, you know, in the one project that I look up to from this perspective is VS Code, right? So VS Code, you know, it's a Microsoft product. It's kind of cannibalizing from Visual Studio. But on the other hand, like, that team has made, like, really good decisions about making it a tool that is generally useful for all developers and not over-indexing on the business case for it. And I think they've had huge success because of that. So I guess my position here is that you should build a tool that is most useful to developers and that they truly love, and the business case will work itself out.
Thank you. I really enjoyed the talk. I had a quick question. I think you mentioned before about you can't like stew on an idea for so long, and then and velocity is important. Please correct me if I'm wrong, but I thought at least like I think GitHub is not like startup level lean, and so I'm having a bit of a difficult time like associating the word velocity and a big company called GitHub together. How do you manage to keep velocity in your team?
Yeah, so this is an important point about how our team specifically, GitHub Next, is set up, as opposed to being the rest of GitHub, which has to operate at a sort of a more measured pace because you have enterprise customers who've signed agreements, and if you change the UI, like, people are going to be upset. So in GitHub Next, we're a small team. We're like 20 people. We have a lot of autonomy to sort of build things as we see fit. And so this means that, you know, we're able to move quickly in a way that like production teams cannot. And you know, we own decisions ourselves, right? So like when we're building Copilot, we don't have to negotiate with you know, someone in some other team to do something. We can just make a decision within our team and move on. And that actually is what enables a lot of this velocity, is this sort of you know, the combination of having people who are empowered to make the decision and make good decisions, and also, you know, having the autonomy to be able to make that decision without, you know, showing 10 decks to executives and so on.
Thank you.